right, boys and girls. So here we are with Chapter 9, Lesson 1. We're starting a new chapter, and in this lesson, we're going to be talking about line plots. Line plots is a way of graphing information, organizing information. So let's go ahead and get started by writing the objective of this lesson. Make sure that you write it as well in your books. The objective of this lesson is we will make and use line plots with fractions to solve problems. Okay, so that's the objective also. And this is objective for this lesson, line plots. Okay, so let's go ahead and unlock the problem. So if you need more time, make sure you put pause to copy the objective. Students have measured different amounts of water into beakers for an experiment. The amount of water in each beaker is listed below. So they measure 1/4 cup, then 1/4, then 1/2, then 3/4. So there's a list of, we have a list of data, a list of information, measurements that, were done. If the total amount of water stayed the same, what would be the average amount of water in a beaker? So here they have organized the information in a line plot. And so we have, but it's not complete yet, right? So what we're going to do here is the first step to be able to record this accurately. We want to make a list of how many 1/4 cups we have, how many 1/2 cups we have, and how many 3/4. That way we can graph more accurately. Okay, so we're going to go ahead and count that. So let's check 1/4 cup. So we have here 1, 2, 3, 4, 5, 6, 7. So we have a total of 7 1/4 cups. Now let's count the halves. Okay, so we're counting the number of cups for each amount. And so for halves, now I'm going to use a circle to point out the halves. So we have here 1. Oops, I need the pen. 1. We have 2. That's it, right? So we have 2 1/2 cups. Now we need to count the 3/4. So now let's do the check mark with the red pen. So 3/4, here we have, we have 1, 2. Do you see another one here? 3. So there's a total of 3 1/4 cups. Okay, so we're going to draw now an X for the number of times each amount is recorded to complete the line plot. So the line plot is not complete, right? We're recording 1/4, 1/2, and 3/4. So we want to show 7 of the 1/4. Right now we're showing 1, 2, 3, 4. So that means that we need to add 3 more because we have 7. So that's 1, 2, 3. So now we have 7 X's under 1/4 to match our information. How many halves did we have in our list? We had 2, right? We have 2 halves in our list. So we're going to mark 2 X's to demonstrate that we have 2 1/2 cups. And then finally, we want to show 3 of the 3/4 cups. Here we're only showing 1, so we're missing 2 more X's to show 3 of the 3/4 cups. All right, so now let's go to step number 2. Find the total amount of water in all of the beakers that contain 1/4 cup of water. So there are blank beakers with 1/4 cup of water. So if we look at the data, we have 7, right? 7 beakers with 1/4 cup of waters. So they are blank forts. So if we're counting how much water we have in total, we have how many quarters? 7. So we have 7 fourths, right? Or we can rewrite this as 7 fourths, like this. And if we simplify this to a mixed number, we can write this as 1 and 3/4. Oh, that should be a fraction. Let's write it here. There you go. So we have, or 1 3/4. So we completed the statement because we're just reading the information. Like if we wanted to know how much water we have of the 1/4, we have 7/4 or 1 3/4 cups. And so we're gonna do the same for the other items. So now we're gonna look at the 1/2 cups. Find the total amount of water in all of the beakers that contain 1/2 cups of water. So we want to know how much water we have in all. And so here we're going to complete the statement. There are how many beakers with 1/2 cup? We look at our line plot and we see that we have 2, right? So we have 2. There are 2 beakers with 1/2 cup of water. So there are 2 halves. Okay, 2 halves based on that information. Or if we write this as a fraction, we have 2/2 because that's 2 halves. Let me use the math symbol. So that's 2 halves. Or if we simplify that, 2/2 is the same as 1 cup. Okay, now let's go step number 4. And so now we want to find out the water in all of the beakers that contain 3/4. So we look at our line plot. 3/4, we have 3 x's. That means that we have 3 of those cups. So we're going to multiply 3 times 3/4. That's another way of doing it. Okay, we have 3/4. And we already know how to multiply fractions. So we know that every time we have a fraction, a whole number, we write it as a fraction by putting a 1 under. And that's the same. 3/1 is the same thing as 3. So now we multiply. And when we multiply fractions, we multiply the numerator times the numerator, denominator times the denominator. So that means that 3 times 3 is 9. And 1 times 4 is 4. So in total, we have 9/4. Now we're going to write this as a mixed number because right now we have a fraction greater than 1. So how many times does the 4 fit into the 9? 4 goes inside the 9 twice, right? Because 4 times 2 is 8. And then the leftover is 1. And that would be 1/4. So you should know this from our fractions unit. Okay. Another way to have done that is you could have divided 9 divided by 4. And you think, how many times does a 4 fit into the 9? 2 times, right? That's how I got my whole number, 2. 2 times 4 is 8. And then I subtract. I have 1. The remainder is 1. So when we have the remainder, we write it as a fraction. The remainder is the numerator, and the divisor is the denominator. So that's how we got 2 1/4. Now let's go to step number 5. Add to find the total amount of water in all of the beakers. So we're combining all the water. So we take all of our answers. We had 1 3/4 from step number 2. We had a 1 from step number 3. And we had 2 1/4 from step number 4. And we're adding all of this together. So we don't have to change the denominator when we're adding these because they all have the same denominator. So 3/4 plus 1/4 is 4/4. And we add the whole numbers. 1 and 1 is 2, plus 2 is 4. However, 4 and 4/4 is the same thing as 1. So we're going to combine that. That means that our total is actually 5 because 4/4 is equal to 1. So we're just combining the whole number plus the simplified fraction, which is 1. That is 5. And finally, to find the average, when we find the average, we basically divide, we add everything. So we already added everything. And then we divide it by the however units we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. we have 12 measurements here in total. Or you can count the X's. We have 7, 8, 9, 10, 11, 12 X's. So now we divide our total amount of water divided by 12 cups that we had in all. And that will give us the average. So 5 divided by 12 is, remember that we can relate division to fractions. So that would be 5 divided by 12 is 5 twelfths. And we cannot simplify that. So that means that our final answer is we had 5 12 cups. The average, so the average amount of water in a beaker is 5 12 cups. All right, so remember, the average is when you add all of your numbers together, your totals, and you divide it by how many numbers you have. So let's do another example, but we're going to do another example down here. But before we do that, let's take a look at this tip from our book. It says you can use the order of operations to find the average. Solve the problems as a series of expressions that use parentheses and brackets to separate them. Perform operations from inside the parentheses to the outer brackets. What does that mean? So the information that we did here, all the steps that we did, we could have written it out as a numerical expression. So we had 7 of the 1/4, we have 2 of the 1/2, and we have 3 of the 3/4. So if you look here, what they did is that they put in parentheses 7 of the 1/4. We were going to multiply those, so we put it in parentheses, and then we had to add the next data, which was 2 times 1/2, because we have 2 of the halves, and then we had to add the 3 times the 3/4. So this, if you compare it to the top work we did, this was step number 2, step number 3, and step number 4, and then step number 5 was to add them, right? So this was step number 5, and then step number 6 was to divide it by 12. So that's basically all the steps up there, but in just a operation. And then after doing that, so now we could just use the order of operations, meaning we do parentheses first. So 7 times 1/4 was 7/4. And then we multiply 2 times 1/2 was 1, because, or 2 halves. And then 3 times 3/4 was 9/4. See? So, and then that stays in the brackets. And then we solve the brackets, which was adding. And remember, we got 5, okay, from step number 6, I'm sorry. And then our final answer was 5 twelfths. So this is just an example of how you could have done that using order of operations. All right, so we're going to go ahead and go to the next example. In the next example, we have Rain divides 3 2-ounce bags of rice into smaller bags. So here's the bags of rices. The first bag is divided into bags weighing 1/6 of an ounce each. The second bag is divided into bags weighing 1/3 ounce each. And the third bag is divided into bags weighing 1/2 ounce each. So we're going to find the number of 1/6, 1/3, and 1/2 ounce rice bags. Then graph the results on the line plot. So we're going to be doing some graphing. So we're going to follow these steps. We're going to write a title to your line plot. It should describe what you're counting. So in here, what are we describing? Okay, we're going to make a title for this. What are we describing? We are describing the weight of the rice bags. Hold on. I want to finish this example. Okay, so here we have the weight of the rice bag. So when we finish this example, I have something to show you guys. Now, that's what we're counting. We're counting the weight of the rice bags. Now we're going to label 1/6, 1/3, and 1/2 because those are our 3 different measurements. And they did that for us, right? 1/6, 1/3, and 1/2. And our step number 3, we're going to use division to find the number of 1/6 ounces, 1/3 ounces, and 1/2 ounces that were made from the 3 original 2-ounce bags of rice. So in this case, we have, uh, we're dividing 2, and we're dividing it by 1/6. Okay, so when we divide the first bag into 1/6 ounces, we're divided by 1/6. And remember that when we divide by a fraction, we're actually going to multiply by the reciprocal. So we flip, remember, the fraction. In other words, we would be multiplying 2 times 6, because the reciprocal of 1/6, if we switch it, the 6 goes on the top and the 1 goes in the bottom. And so it will end up like this. And 6/1 is the same thing as 6. So 2 times 6 is equal to 12. And now, so I'm going to do the same for the rest. I'm going to divide 2 divided by 1/3. If I switch the numbers to find the reciprocal, I would be multiplying 2 times 3. And 2 times 3 is equal to 6. Okay, so how did I get 3? Because I found the reciprocal of 1/3. And the reciprocal means that I switch the numbers. The numerator becomes the denominator becomes the numerator. So that's how I got 3. 2 times 3 is 6. Now let's look at the next set. 2 divided by 1/2. And we do the same thing. We find the reciprocal of 1/2. We find the reciprocal of the second digit. The second digit is the divisor. So got to remember that. So that would be the reciprocal of 1/2 is 2, because when we put the 2 in the numerator and the 1 in the denominator, that's 2 or 1, so it's the same thing as 2. So 2 times 2 is equal to 4. Now we're ready to graph, and that's our fourth step. We're going to draw an X above 1/6, 1/3, and 1/2 to show the number of rice bags. So on the first one, on the 1/6, we're going to show how many rice bags, and the number of rice bags is 12. So we're going to draw 12 X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we're going to draw the 1/3 bags, and we have 6. So we're going to draw 1, 2, 3, 4, 5, 6. And finally, we're going to draw 4. So that's 1, 2, 3, 4. And we just plotted in the line plot that information, that data. All right, so there's more examples. You'll have an opportunity to try this in the next slide.